Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent. So I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to nearest percent, so that would be 20%. Or actually it would be 21% because this would round it up, so 21%. So in this question it says that 450 people are in total, and we know that represented by 360 degrees in a circle. But what I want to do is work out what 1 degree represents. So to get from 360 to 1, we divide by 360. So we're going to do the same on the other side. So 450 divided by 360 is 1.25, or 1 1/4. So 1 degree represents 1/4, or 1 1/4. People. Okay, and we're asked to find how many people answered no, which is 140 degrees. So we want to find out what 140 degrees is. So we obviously need to times that by 140, and we're going to times the other side by 140 as well. And when we do that, we get 175. So it'd be 175 people said no. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. The multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane, and so let's do Lenny, and so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds. And we're going to do that by finding out what €1 is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here. And there's no reason I picked those, just pick those at random. And we look at how far it's going to cross. So it's gone across 10. How far it's gone up. So it's gone from 24 to 36. So it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113%, because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13. And we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom actually, that might be easier, and draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. To find the density of this wooden block, we're going to have to first of all find out what the volume of the block is. And volume is the cross-sectional area times by the length. And the reason why it's that is it's a prism, and all prisms you just find the area of the cross-section and we times it by the length. So what is the shape of the cross-section? Well, the cross-section is a triangle, and the cross-section is this part here. I just quickly colour it in. And so we're just finding the area of that triangle, so half base times height. And we're going to times it by the length. And the length is how 3D the prism is. So the base is 3, the height is 14, and the length is 5. And when you do that, you get 105 centimeters cubed. Right, now we need to find out what the density is, and the formula for density is mass divided by volume. The mass is given to us in the question is 246. The volume we've just worked out, is 105. And so you do 246 divided by 105, and you get 2.342 blah blah blah. And then we round that to 2 decimal places, which it says in the question to do, and that would be 2.34 grams per centimeters cubed. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3. But 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So for us to work out the average speed, so we've got to first of all remember the triangle. So average speed is total distance over total time. And we're told to find the average speed before stopping. So stopping is shown with a horizontal line on a distance time graph. So it's up to this point here. So the average speed will be the total distance, which would be 20, over the total time. So 9:30 to 10 will be 30 minutes, but since our units will be kilometres per hour, we need that in hours, which will be a half. And 20 divided by a half is going to be 40. So our answer is going to be 40 kilometres per hour. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph, you only need 3 points. With a curve, you need as many as you can get. And now we're actually given a table here to fill out. And so I'm going to start off with a 0 here. And here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11. So it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1. So y equals 1 squared plus 11. 1 squared is just 1. 1 plus 11 is 12. Same again for 2. 2 squared plus 11. 2 squared is 4. 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative, you actually get a positive. So minus 1 squared is just 1. 1 plus 11 is 12. And then minus 2 squared plus 11. Minus 2 squared is 4. 4 plus 11 is just 15. Now you can see here we get a nice little symmetry. And we're going to plot this onto our graph here. So 11 is going to be here. 12 is going to be here. So both of these are 12. And 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically, it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line. And we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours. And that should be good enough for full marks. Let's just try it again. Just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this, where it just missed that point out, or something like that, that would not give you the mark. You just want one nice smooth. Just slip there a little bit. Nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. and so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chilton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way, so we'll do D there. Distance from Chilton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chilton at 9 o'clock. He drives from Chilton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes, or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A.
To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that will be 19.99 centimetres. Whenever we're asked to compare two box plots or two cumulative frequency graphs, or a cumulative frequency graph and a box plot, you're always going to be comparing two things. You're going to be comparing the median and the interquartile range. Now if we do a little table, like a good table, and we've got male and female, and we're going to work out the median, which is the first thing we have to compare, and the interquartile range. And it can actually just be the normal range. We don't need to pick the interquartile range. So the median for male is this line here, this bit here. And if you look down, that is 22. And for females, it's this one here. If you look down, that's 18. And we just go write a sentence. So you say something like the median is higher for males, brackets 22, always show your values, than for females, brackets 18. Okay, easy. Next we're going to do interquartile range. Interquartile range is slightly harder because you need to do the distance between the upper quartile, which is this line here, and the lower quartile, which is this line here. And so that would be 24 take away 19, which would be 5. And for the females, it would be 28, which is this one here, take away 16, which is this one here, and that will give you the answer of 12. So the next sentence we say is the interquartile range. They don't mind you writing IQR, that's absolutely fine. Is, now you can say lower for males or higher for females. I'm going to say lower for males, brackets 5, than for females, bracket 12. Now the median is basically on average the males are higher. Okay, so it's just an average, says on average they're higher. The interquartile range is an interesting one. Anything to do with range is about consistency. So it's actually quite good in many instances to have a lower interquartile range because it just shows you're more consistent. So you say the sentence could be that the males are more consistent because the interquartile range is lower. Generally speaking, the higher the median, the better. The lower the interquartile range, the better. Apart from if you're talking about things that like the time it took you for a race, you kind of want the median to be lower. Still, you want the interquartile range to be lower because you want to be consistent. We've got to first of all work out how many jumps there is between our shape and the centre of enlargement. So I'm going to pick a point at the top of our shape, and we can see that there are 2 jumps to the left, and 1, 2, 3, 4, 5, 6. So we've got to go 2 and then 6. And the reason we do this is we're looking at a scale factor of -2, which means we're going to go through the centre of enlargement. And what that means is we're going to do 2 left and 6 down another 2 times, because it's -2. So we're going to go 1 and 2, 1, 2, 3, 4, 5, 6. And that would be a scale factor of -1 if I plotted that point. We're at -2, so we're going to go another 2, 1, 2, and another 6. 1, 2, 3, 4, 5, 6. So our new coordinate is down there. And we can go ahead and do this for the other 3 coordinates. I'm going to do it for the bottom left point. So we go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, so the coordinate's going to be there. Now I can do it for the third one, or I can just kind of work out where it's going to be, because if I draw in this shape, well, we've got the 2 coordinates here, so it's kind of on the y-axis. You can't really see it too well, but we know the other one is going to be 4 to the left, because on our original image it's 2 to the right. And so a scale factor of -2 would be, instead of 2 to the right, if you negate that, it's going to be left, and if you times it by 2, it's going to be 4. And let's just draw in our last part of it, and that's going to be our new triangle there. And it says to label it B, so we're just going to put B on it. I'm going to start off by labeling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around B and C are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is, so what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah blah blah. It says it wants its 2 decimal places, so that's going to be 2.49. We're asked to solve this quadratic, and we're told that we're going to put the answers to 2 decimal places, so we're going to be using the quadratic formula. For the quadratic formula, we need to work out what a, b, and c are. A is the coefficient of the x squared. Now, it doesn't look like it has a number before it, but it does. There is a 1 there, so a is 1. B is the coefficient of the x, which is 5. And c is the number left on its own at the end, which would be minus 20. So we're going to write out the quadratic formula, and we're going to substitute in the value. So it's minus b, and I always put the values I substitute in brackets on the calculator, because if they're negative, we can get into problems. B squared minus 4 times a times c over 2a. And if you type that into the calculator with a plus there, so change that for a plus, you're going to get the answer of 2.623 blah blah blah. If you go back on the calculator, use the cursor keys to change that to a minus, you get the answer of minus 7.623 blah blah blah. Rounded to 2 decimal places, that's going to be 2.62 and minus 7.62. Capture-Recapture is a way of estimating total population sizes, and it uses a really nice formula, which is n equals little n times little m over big N. Now, n and n, the little ones, are population, are sample sizes. Okay, so they're the size of each sample, and this big M here is the amount that were marked in the second sample. Okay, so n is the first sample, m is the second sample size, and then m is marked. So marked in the second sample, because obviously you're going to mark all of them in the first sample. So what you do is you catch an amount of a trout in this case, mark them all with any kind of marking, and then you capture again, and capital M is the amount that were marked from the first sample in your second sample, and then capital N is the estimated population size. So that's what you think the overall population size is going to be. So here we caught a sample of 84 and tagged them all, and then we released them. Then we caught a sample of 56, and we found that 15 were tagged. And so when you do the sums on that, it's going to be 313.6. And when you round it to the nearest integer, because obviously you can't get 0.6 of a trout, we estimate it to be 314. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half A plus B times the height. And the two parallel sides are on the left and the right. So it's going to be half times this part here, which is 40, plus this point here, which is 160. And then the height is actually the width. So the height is this bit here, so that's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide. And again 160 tall, so 3 times 160, which would be 480. And so we need to work out the total area, and we do that just by adding the two together. So 200 plus 480, which will be 680. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. There are two shapes we're interested in this question. There's this sector here, which we can work out the area of. And there's this triangle here, which we can work out the area of. What we do is we work out the area of the sector, and then we subtract the area of the triangle. So I'm going to start off by working out the area of sector. And we know that that is the angle that we have of the circle times by the area of the full circle. So the angle we have is 39 over 360. And then we've got pi times 10 squared. Type that into your calculator and you get 34.033 blah blah blah. Next we're going to find out the area of the triangle. And we use the, well, if you have a look at the triangle, we've got 10 centimeters here because that is also a radius of the circle. So we've got two lengths and we've got an angle, so we can use the half AB sine C formula. So we've got half AB sine C. And so A and B are going to be our lengths, and C is going to be this angle here. So we've got a half times 10 times 10 times sine the angle, which is 39. Then when you work that out, you get 31.466 blah blah blah. Okay, so to work out the area of the segment, all we're doing is the area of the sector, like the full area, take away the bit we don't want, which is the triangle, and that will leave us the area of the segment. So we're going to do the 34.033 blah blah blah, take away 31.466 blah blah blah. And what I've done is I've saved them on my calculator so I can do it precisely. And when you subtract them, you get 2.567 blah blah blah. Once it's two decimal places, so we're just going to round that to 2.57. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. the P part inside the bracket is going to be minus 5, and the Q part is going to be minus 86. So we're asked to first of all complete the square, so that's what we're going to do. And to complete the square, we've got to remove the minus from the x squared because we've got to have x squared. So we're just going to factorise out the minus 1 effectively. We have minus x squared, and this has to be minus 10x. And then we're just going to leave the plus 7 on its own at the end there. The reason this is a minus 10x is a minus 1 times minus 10x is 10x. Okay, so we're going to leave that, and we're going to just focus on the x squared minus 10x. So the way we complete the square is you do a bracket, and you have x, and then you halve what the coefficient of the x is, so that'd be minus 5, and then square it. Now if you expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, right, we need to get rid of that 25. And so I'm going to now expand the bracket with the minus on. So we've got minus x minus 5 squared plus 25 plus 7. And then we're just going to add the 25 and the 7, and you should get 32. Now, if I'm to draw the graph of y equals minus x squared, it's just a graph that looks like this. But more importantly, that their maximum point on this graph is at 0, 0. And if we remember our graphic transformations say that if we have a minus 5 on the inside of our function, and so comparing this function, say this is f of x, part of this equation here involves a minus 5 inside the function. That minus 5 moves the graph to the right 5. Okay, so we're going to move it to the right 5. Similarly, if you have a function and you've got a plus 32 on the outside of it, which we have here, it's going to move it up 32. So instead of our maximum point being at 0, 0, it's moving to the right 5, so the x coordinate would be 5, and up 32, so the y coordinate would be 32. Iteration is a process to find a solution, and we're asked to find the solution for this correct to, or a solution for this correct to 2 decimal places. Now what we're going to do on a calculator is something a bit weird. We're going to literally just press the number 2, and then we're going to press equals. When you do that, it stores the 2 in the calculator's memory. The next thing we're going to do is type in 13, and as soon as you type in the 1, the 2 will disappear. So 13 minus square root of answer. And most calculators call it ANS, answer. On the Casio calculators, it's at the bottom right and then left 1. It's next to the equal sign. And then next time we press equals, what it will do is it will get this 2, it will feed it into this, and then it will work out what the next solution is. When you do that, you get a solution of 11.59 when rounded to the 2 decimal places. Press it again, you get 9.60, again rounded to 2 decimal places. Again, 9.90, 9.85. So it's getting closer to something now. 9.86 and then 9.86. So our solution, our answer, is going to be 9.86 because as soon as the number repeats, then you stop and you write down that answer. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the 2 lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A,
we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So first thing I'm going to do is I'm going to put my lines in because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side because that gets rid of the denominator, and it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, what is it, 56,100. I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870. And we're going to take that away from both sides. So take away 1870x from both sides. And that will leave 5100x on the left hand side. And then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So A is 17. So at the point on the graph where x is 12, it's this point here. And what you need is a ruler. And what you're going to do is rest it on so it becomes the tangent of that point. So I'm going to try my best to do it here. I'm just going to draw it out, and this is going to be my ruler, and I'm just going to move this into place. So we want that to be a tangent at x equals 12, which is about here. And then what you do is work out what the gradient of that line is. So I'm just going to draw a line across and up, and we know that gradient is the change in y over change in x. The change in y is 2, and the change in x is 1. 2 divided by 1 is just 2. So the gradient at x equals 12 is 2. Now notice it says x equals 12. It's a curve, so the gradient's constantly changing, but an estimate of the gradient at that point is roughly 2. And you just need to make sure you rest the ruler down, and then until you're happy with it, draw the line like I've done with the blue line, and then just work out the gradient of that. And if you just show all your workings, show the examiner how you've come up with the value, even if your gradient's slightly off, you might still even be able to get full marks on some of the papers, if not 1 out of the 2 marks maybe. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.